problem solving. So this is the actual more mathy part that we're going to talk about. And actually a lot of what I'm talking about here is not necessarily in the textbook, but it's going to give you a good context of how to approach the problems throughout this course. And I want to connect it all to the different degrees you guys are taking, because everybody always asks, I have this degree, why do I need to take this class? So I'm trying to address a lot of things here. So first off, did you know that as a university, we have what are called 6 core professional competencies? These are things that we have talked to employers and we're like, these are the skills that we want your graduates to know. So these are the things that you're meant to get out of like gen ed courses, which this class is a gen ed. And so 2 of the ones that are relevant to math are critical thinking and problem solving, and then data aptitude. So data aptitude is pretty obvious that that's related to math. So it says developing information literacy and the capacity to manage data with subsequent finding, structuring, evaluating, interpreting in order to provide meaningful analysis to accomplish a specific purpose. What this basically means is being able to see numbers, analyze it, like being able to find the sum or solve a problem or graph the whatever you have, understand what that graph is telling you or understand what the numbers are telling you, and then using that data to go forward with something. This is actually really great for people going into business, because if you're owning your own business, you need to look at the numbers to determine, is my business making money? Is it not making money? Did that ad help us, or did the ad not help, or did we get fewer views because of the ad? You want to really look at the numbers, and a lot of it is done graphically. So that's data aptitude. And so you'll learn that in this class, and that's why half the class is graphing, learning about interpreting graphs, analyzing it, understanding what the numbers mean, and word problems are key towards this as well. The other one, the longer one here, critical thinking, problem solving. So it says using analytical reasoning when gathering and evaluating relevant information to effectively formulate possible solutions for an issue, problem, or a variety of issues. This includes the ability to recognize potential consequences of a decision. So very wordy. There are lots of different types of problem solving, lots of different types of critical thinking. In math, we're teaching you to use data in order to do this. You're solving problems using data, analyzing data, and then making decisions. It also, it says to effectively formulate possible solutions. One thing that you're learning in math is like trying to decide, what technique should I use to solve this? Which would be the most efficient way to find this answer? Or how do I set up this equation? How do I know what I'm looking for? There's a lot of questions that you ask. A lot of questions that people ask because they don't know, they're like, I don't know how to do this problem. Where do I start? Those are questions you ask for critical thinking. So you guys are going to be doing a lot of problem solving and critical thinking. And this is why math is required as a gen ed. Some degrees don't require college algebra, but if you're in this class, you're probably in a degree that requires college algebra, and there's specific reasons for that. But you do learn a lot of critical thinking and working with data. And yes, you're probably not going to solve an equation in your job, but when you're solving the equations here, you're learning these other skills that you will do on your job. So that's what you're getting at. And you may not be doing exactly what you see in this class, but you're learning ways of thinking that you're going to use in the world. And that's what you want to take away from this class. If you're somebody that hates math, don't think, oh, when am I going to do this? Yeah, you're probably not going to solve an equation, but the thinking is what you will use, and that's really important. So for those of you who are business majors, getting a degree in business, maybe business administration, maybe you're getting management, HR, accounting, you guys all, I think nearly every single one of those requires this class. So I'm sure many of you are in this actually I'm curious, I can do a poll. Let me see if I can set up the poll here. So I'm going to just, a poll, it should have popped up in your, are you a business major or are you not a business major? Let's see what we've got. So, okay, so it's about half and half, which is what I expected. Yeah, because pretty much if you're in business, you have to take this class. So, because basically about half of you are in business, you may notice throughout the class, I'm going to talk about how is this relevant towards business. So one of the things that like our business programs say is that they want you to demonstrate critical thinking through applying decision support tools, and using data is a decision support tool, basically using data to make decisions. And so that's one reason why they're having you take this class. So they require you to take this class because they want you to learn how to work with data, but you also need to have some understanding of algebra to take economics classes, to take accounting classes, because you're using formulas in both of those, and formulas are basically algebra, finance classes, and statistics. So because you have to take courses that involve math, even if it's just plugging in numbers in a formula, you're required to take this class first so that you understand how to do that, how to learn how to plug numbers in a formula. And for statistics in particular, you do graphing in that class, you do write equations. Statistics is more algebra-y than the other ones, so that does require this class first. So that's why you guys are in this class. And so just keep this in mind, that what you're learning will help you in those other classes. You're here for a reason. Okay. Now, occasionally, not very often, we have people that are in this class getting a criminal justice degree. So criminal justice does not require this class, but those in criminal justice do sometimes work with statistics, like if you have to do crime statistics, and so math does help with that. But it's not critical, so that's why it's not required. Next, this is where I think everybody, the other half of the class is at. I think the other class half is either in engineering or computer science. So it looks like 3 of you guys, and you know, not the entire class is here, so there's probably more of you, but math is required for engineering. So you are required to take this class, and people in engineering usually have to go all the way through calculus. So this is like your starter math class. Math is the foundation of engineering. Basically, most engineering has some sort of math in it. I actually have a computer engineering degree, and the reason why I then went into math is because when I decided I wanted to teach, I had like half of the math degree already done. Like it only added, I think it added like 2 years, and most of it was actually my education classes, not my math degrees or math classes, because I had already taken so much math. Math is just what you need in order to do engineering, because a lot of engineering is needing to understand circuits, and you've got you know, your voltage, your current, and you have all of these things. And when you're in engineering technology, usually you don't really need to you know how to read a circuit. You've got all these tools that can read the numbers for you. But what you get when you get a degree in engineering versus just, you know, maybe a certificate or just working in the field, is that you learn the theory behind it. Like, why does this circuit behave this way? What is the math that tells us the circuit behaves this way? So any of the engineering degrees, you actually, it relies a lot on physics. Physics, half of physics is basically working with circuits, magnetism, all that kind of stuff. And physics is applied math. So you've got math. And actually, in engineering, some of the goals for when you graduate, some of the goals that they want you to have, and this is coming from actually our course catalog, is to be able to apply a knowledge of math, science, and engineering, basically to problems. You're conducting tests and you're measuring, you're analyzing your numbers. You're using those numbers to improve things, so you have to work a lot with data. We've also got apply natural sciences and mathematics at or above the level of algebra as one of the goals when you're building computer systems and software. And then you're also going to be using statistics and transforms, discrete math, all this math in order to understand how these systems work. So engineers, you're in for a lot of math. This is going to be a great foundation for you. And then here are computer science people. And I'm lumping computer science as also the information technology or health information systems, anything where you're kind of doing some sort of programming. So computer science, math is also the foundation of computer science. A lot of my computer science classes were actually in the math department because they were inherently math and then used towards computers. So specifically for math, you are expected to use math in computer science to solve problems. A lot of the time it's just basic algebra, the most basic stuff, solving equations. I've had students who have taken some of the classes like CS 265, and they said that they actually ended up using a lot of math in those classes when they were writing programs. So, and just be aware that you are going to be using math. And actually, the whole idea of a function, which is something we talk about in math, is what programming is. Programming is actually writing functions. And so you're actually writing, you're using a mathematical idea, but in a computer context, not actually solving like a math equation. So in computer science, you are going to see a lot of math, especially with the theory. It comes up a lot when you talk about like run times and trying to get something more efficient. You want to speed things up and trying to figure out how long something takes. And so there's all that kind of stuff. And then the last different type, and this is my last poll, are people who are going to be in healthcare related fields. I don't think there's going to be too many here. Yeah, those are all hard no's. Because again, this is like criminal justice. It's not required, but it's helpful. But if you are in healthcare, we do have the health information sciences, and that's more computer sciencey, so they do have to take algebra. But basically, it's all about analyzing data, making sure your measurements are okay. So you have to kind of understand the numbers, learning how to do unit conversions, which actually can be done with algebra. Maybe understanding some statistics if you're reading a medical journal, but it's more of an analyzing using data kind of thing. So you do get that out of this class. So I've tried to address why people are here. What does this have to do with problem solving? Well, these all require critical thinking. All of these degrees, it's something you have to do in math. It's, like I said, it teaches you a way to do this using logic and procedures. So here's where we get into the math part, and this is what's going to be helpful for you guys as you go forward doing your math homework. So there's a mathematician, George Polya. He's a Hungarian. He actually passed away in the 80s, and he wrote a book, a famous book, like everybody's modeled their problem solving after this, called How to Solve It, and it's on Amazon. And this has been basically how, basically he wrote a whole book on how to problem solve with, here's some steps you should do, and then here are some things to try if this doesn't work. Like that was what the entire book was. And he broke it down into 4 steps, and these are the 4 steps you should follow every time you do a math problem. So this is how you do a math problem, and this is how you get successful at doing math, as you're following these steps. So the first step is to understand the problem, and that basically means, what do I need to do? Know what it's looking for, what you need to do. Step 2 is to make a plan. Figure out what are you going to do to solve this. Step 3, carry out the plan, so you're actually solving it. And then step 4 is look back, which basically means check your work. So Polya, oops, I have a typo here. I wrote Polya. Spell check does not catch his name. It just kept marking it wrong, so I didn't catch that. He said basically if you can't solve a problem, then there may be an easier problem that you can solve that can get you partly there, or look for a related problem to solve and see if you can do that. And this is a good tip when you guys are doing the homework. If you're struggling on a problem, try to find something related to it, or try to find a smaller thing that you can do and then build up to it. So step one, when you guys are doing math problems and your step one is to understand the problem, here are some questions to kind of help you get started. And this is great for word problems. So first, what are you being asked to find or show? Like what is it wanting you to do? What answer are you looking for? Can you restate the problem in your own words? Like, can you take what it says in our mathematical definition and our technical words and put it in a way that you can understand what it's looking for? Can you think of a picture or a diagram that might help you understand the problem? And that's good for word problems. I draw pictures for word problems all the time because it helps me understand what is going on. So definitely, if you have a word problem, try to draw a picture. Is there enough information to enable you to find a solution? Tip, in this class, yes. We don't try to trick you by leaving out information. You'll always have enough information to find an answer, even if that answer means there's no solution. But there's at least a process you can still do. Do you understand all the words used in the stating of the problem? Like, when you read the words that they tell you, in addition to the math, do you know what those words mean? If you don't, that's where you need to look in your dictionary so that you see, well, what does this word mean? What is it telling me to do? And that looking up the words can give you a tip on, okay, this is how I know what procedure I do, because I looked up, it's this type of word, this is what I do. And in Alex, I said there's that dictionary button. When you look up a word in Alex, they actually give you an example as well of what that means. So that's going to be very helpful for you. So if you don't understand a word, look it up in the dictionary and they'll give you an example of what it means. And then do you need to ask a question to get to the answer? Like, do you need some help? Do you need to know more things? That's when, you say, okay, I'm really not sure where to go from here. This is where I have to get help. So start by trying to figure out what you know, what you don't know, what you need to figure out so that you can, figure out the next step. So you're just asking you these questions to kind of get you to the right places. Okay, this is what this word means. Let me check that. Step two, once you've kind of understood what are you looking for, what does it want you to do, I know what all these words mean, this is where you come up with your plan. So in math, there's specific plans that you do. So first, variables. So in a regular equation, you're given letters already to use, but if it's a word problem, you get to pick the letters that you want to use. For word problems, this would be where you start drawing pictures or making tables if you need to. The book represents writing a verbal model. Basically, write in words what you're supposed to do. And then you take that sentence you wrote and you translate it into an equation. And this is literally called translating. Basically, and you may have seen this in the discussion if you already gone through the discussion today, but math is a language. And so you can take certain words in English and it means something in math. Like there are certain words in English that tell you to add. There are certain words to multiply. So you're going to use those words and create your equation from there. But there's other things that work. Look for patterns. That's really important. If you can see patterns between every problem that you solve, it's going to make things easier for you because you'll see that you're doing the same steps over and over and over again. So look for patterns. Use models or formulas. Sometimes you can do guess and check. Sometimes you can work backwards. If you if you know what the answer is, but you're not sure how to do the math to get there, you can try to undo what you did in your head sometimes. So those are some additional tips. Step 3 means actually doing the problem, solving it. So like step 2 is where you create an equation for a word problem. Step 3 is where you actually solve that equation. So there are certain words that tell you what to do. Simplify has a specific meaning that tells you what you're supposed to do. Evaluate has a specific meaning. Solve. Those are words that are telling you what the plan is, essentially. But one thing is you don't want to rush. Don't try to rush through your math because that's where you will make mistakes. And this comes back to being patient. So you want to make sure that you are writing down the right numbers. It's neat so you can follow your work. You're showing every step so that when you're on the quiz, you can go back to your notes and see, that was what I needed to do. It could take multiple steps. Don't give up, because if one way doesn't work, try something else or ask for help. Don't spend hours on one problem. If you're really getting stuck, that's where you should immediately ask for help. Or some students have said they just take a break, they go walk away for an hour and then come back to it and they're like, oh, this makes sense. I know what I needed to do. So don't give up, have patience, don't rush, take your time. So just some tips for the actual solving process. And then the last step then is to basically look back, check your work, make sure your answer makes sense. And this is especially important if it's a word problem, because let's say you're solving a problem and they want to know how long it took somebody to mow a lawn and you got a negative answer. Well, that wouldn't make sense because you can't have negative hours or negative minutes. So once you get your answer, always ask yourself, does this make sense? For the specific problem that I have, does this answer have meaning? Does it make sense? Is it reasonable? If you solved a problem about how long it took somebody to mow and you got like 10,000 hours, that's probably not reasonable. But if you got maybe 1 hour or 2 hours, okay, that's probably reasonable. Other things to do, and this is something that I don't think a lot of people do, is to think about what worked while you solved that problem, what didn't work, where did you get stuck, and why do you think you got stuck there? Because those are the parts that tell you that you need to spend more time on that or get help to understand that better. So you're going to want to maybe make notes of, I'm not sure of this step, I don't know why we did this, or I got stuck trying to do this, so that you can get help to understand that better. And that will really help you learn from your mistakes. And then are there other problems where this may be useful? Because then you're seeing the patterns. I use this technique here, it could also work here. So they can speed things up for you in the future. And then lastly, to be successful in this class, really try to follow these steps. I know it seems kind of a lot, but these are good problem solving steps, and they can at least give you some direction if you get stuck, and it will start to become second nature the more you do this. Because really with math, you have to really kind of think about what you're doing so you can start to see patterns, learn from your mistakes, because that makes it easier for you in the future. And actually, this is coming from my December 2020 term that finished at the end of, it just finished like a week ago. And one of my students said, this course helped me a lot at work, but not so much with the equations themselves. Hours of critical thinking, trying to learn all the lessons through screen, definitely increased my critical thinking on the job and made me a better tech. So as I said before, it's not the equations that you're going to use, it's the critical thinking that's going to help you, and you're going to get that in this class. So that is my whole little thing about problem solving. For future live sessions, they will be definitely more actual doing math, but I wanted to start first day of class with tips for how to approach the problem so that you can start off with the right strategies from the very beginning. I thought this would be a good thing to start off with.